We've taken a look at inequalities, and we saw that the answer to an inequality is a range of numbers, typically. We also saw that if we divide that solving inequalities works the same as if it was an equal sign, unless you're dividing or multiplying across by a -1, by a negative. It will flip the inequality the other direction. Well, now we're going to look at something called compound inequalities. And what we're going to have is two inequalities at the same time. Now, there's two different versions of them. Sometimes we're going to have, my pen is working here, sometimes we're going to have and inequalities, where this symbol, this upside down U, is called an intersection. And sometimes we're going to have or inequalities, where we have this is a union. Now, an intersection means that we need the location that is true for both different answers. It's got to be true in both groups. A union is I'm happy with either one. Now, this will make more sense as we get going, so let's get to it, and we're going to start with an and. This is literally two different equations to solve, and they tell us and. So what this means is that we're going to want the solution that makes them both true at the same time. Now, working them is just the same. We have a whole video on that, and so I'm just going to go through that. We don't divide by any negatives. It's just typical solving. Now, let's take those solutions and let's put them on some number lines. And I really recommend you do this. If I were grading this, I don't require that you do the number lines, but it helps to see something which I think most students have a pretty difficult time with. So one solution said we want the x's less than 2. So that's a parenthesis, and it's going down toward the negative numbers. This one is greater than or equal to -3. So I've got a bracket, and I've got the arrow going up. Okay, now what we need, because it's an and, is we are only happy with the values that make both of them true at the same time. Now, if you look at what they've done here, if we're on a number line, do you see that it's this region here? This is where we're overlapping in both of them. And pay special attention to the ends here. I have a bracket at this end for -3, so I'm going to include it. I'm going to have a bracket there for -3. That begins my overlap. On the other end, my overlap ends at this parenthesis when I get to 2. So pay special attention to those ends, but I'm looking for the overlap, and there I have it. And so my solution for an and is where both are true at the same time. Now, I don't know how many I have of these. You can pause it if you want to try this yourself if you feel ready for it, but otherwise I'll work it through. Now, I'm not going to show all the steps of the algebra. Like, I'm just going to go ahead and do this. I'm adding 7, dividing by 4, and I get to this. So again, we have other videos on that if this is giving you trouble. Okay, so I have solved both of these. Now let's put them on a number line. Now, it doesn't have to be perfect, it's just to get the idea. And what I want is x is less than 4, so that's a parenthesis. We're going down this way. Okay, now we also want to be greater than or equal to, so that's a bracket, and we're going to go this way. Now, what we're looking for, our solution, because it was an and, has to be the region that overlaps them both. Now, pay special attention to the ends. It's a bracket at -1, and it will go to 4 with a parenthesis. Okay, so let's try. Is this a different one? I had to pause to cough here a minute, sorry. So if you did not try that last one, I'd really recommend you pause and try this one. Now, it's an and again, so we want that overlap region. So I'm going to work through this. Okay, I did not divide by any negatives, so these are the symbols I would want. Now I want to be less than 3, or I want to be greater than or equal, so I get a bracket, than -2. Now, my overlap region is here, and it's an and, so I need that overlap. So I'm going to go from -2 to 3, paying special attention to those ends. Okay, let's work through here. We're going to jump to theirs. I think something interesting happens here. So I've just jumped to them. I'm not going to step through those. They've worked those for us. Now look what happens. We have two less thans. So when we graph that and we have an and, so we need the overlap, look where the overlap region is. It just so happens to be the very same answer as this one. Do you see what I mean? So if I have these two both going down, the overlap stops right there, which just coincidentally is this top one, where I'm going x is less than or equal to 1/2. So in interval notation, the only place they overlap is here. Okay, try that here. So I'll show you another one if you want to see this, or you can try your own. So I'm going to distribute here. Okay, so 6x. Now I'm just going to go for it again, dividing both sides by 6. Okay, over here. So I'm going to reduce that down to 3/2. Okay, so here's my first one. I want to be equal to 3 or less. And over here, 3/2 would be somewhere about here. That's 1.5. Whoops, I should do it like this. Okay, and what do they want? They want to be, we want to be there, but there's no equal sign, so that's supposed to be a parenthesis. That looks terrible. Okay, now we want the overlap region. So they overlap down here, and it would stop here at this first one. So it just so happens, because they're both down, this is the solution. Remember, we go up the numbered line, so we read it negative infinity to 3/2. And if this was a parenthesis, that has to be where we would end on this one as well, 3/2. Okay, got another one here. Okay, distributing. Okay, now I'm going to graph them. I've got a bracket because it's less than or equal to 1. And I have a parenthesis as we're less than -1. Okay, this is an and again, so I need the overlap, and the overlap once again would only be up to here. So it's once again this one, that answer. So we need to put that in interval notation. It'd be negative infinity to -1. Pay special attention to that end, it'd be a parenthesis. Okay, now this one's interesting. I remember this from earlier. So if I solve these, look what I get. I get x is greater than or equal to 6, or x is less than or equal to 1. Well, this is an and, but they don't overlap. Do you see these are going in opposite directions? So if I'm looking for an and, well, this doesn't work. So they never overlap each other, so there's no solution. There is no region where they overlap, so we have to say no solution. Now I'm assuming that's what's going to happen here because that's how they usually do it, but we'll take a look. Oops. Now I'm going to go ahead and distribute this, save myself some writing. So I'm distributing that -3. Okay, now do you remember how we'd get rid of a fraction? It's being divided by 1/4, but we can just multiply by the reciprocal. It's accomplishing the same thing. And this is going to be 8. Okay, over here I've got -3x greater than or equal to -4. Now be careful, look what happens. So this time we're dividing by a -3. So that's going to flip the inequality sign the other direction. And I'm going to get -4/3. So that's what's going to cause us the dilemma here. If this is -4/3, I've got a bracket going this way. This is 8. I want to be greater than or equal to 8, so I'm going that way. And it was an and, so there's no solution. Okay, pause if you want to try yourself. Again, I have a feeling we already know what this is going to be because they tend to do that. Again, I'm going to distribute this to save myself some writing. So we've got 1/5 x is greater than or equal to 2. I'm going to multiply both sides by the reciprocal. Okay, over here, do it. Once again, I'm dividing by a negative, so that's going to flip an inequality sign the other direction. And I'm going to get positive 6 over 4, which is the same thing as 3 over 2. Okay, so I could graph these, but we're going this way, and we're going that way again. So this is no solution. Because it was an and. There's the next situation, that's going to be acceptable, but not for an and. Okay, so they're also throwing here some, if you ever see a double inequality like this is an and. Now let me see how they did it. Yeah, I'm going to show you this, but I don't recommend you do it. This is a double inequality. It means an and you could literally, if you so choose, work it in two directions at the very same time. Meaning I would add a 7, well I'm going to add it to both the right and the left. Then you could divide by 3, you're going to do it to the right and the left. And while it's true, and that's very quick and very clever, I don't recommend you do it. I find most students struggle with that. And so this is the same as an and problem, and so I recommend you work it like this, where you literally turn it into two separate problems. There's one there, and there's another one over there. Now, if you work it as an and, it turns into the same thing we were doing before. So I'm going to add 7 to both sides. Divide both sides by 3. Okay, let me do this one. Okay, now this is an and we could go ahead and work this right here. If you totally feel confident that you see that this means x is greater than or equal to 1, then go ahead. But I have a lot of students who I'd really recommend you just flip it around so that we always have x on this side. So I'm going to reverse everything here, all of it. So I'm going to flip it around. X is greater than or equal to 1, just so people are reading it right. Again, it's not necessary if you feel confident with that, but I feel like students are often fail to read them correctly. So, and I do too sometimes when it's on the wrong side. So let me hold on. I'm going to do this again. I got ahead of myself. So here's my 1. I want to be greater than or equal to 1. Here's my 5. I want to be just less than 5. Now we said this was an and, so we need that overlap region, and they go over top of each other from 1 to 5. Keep an eye on the ends, and that would be my solution in interval notation. Okay, if you feel like you prefer to work them as like one going both directions at the same time, you can, but I'm going to stick to this. So I'm adding 1 to both sides. Now, there's a negative in the problem, but I never divided by 1, so this is what I got there. Okay. Now I'm going to reverse this. So everything there I'm going to reverse, so I'm reading it right. So I want to be less than 2, and I want to be greater than or equal to -1. Okay, my overlap region is -1 to 2. All right, we got one more of these. Feel free to pause it. So I'm breaking up the whole thing. The whole middle is getting repeated twice. Okay, I'm adding 5. So divide both sides by 2. I get x is greater than 1. Okay, so x is greater as well. Let me reverse it. So you don't have to, but just want to make sure you're reading the sign right. Okay, so I want to be less than or equal to 3, and I want to be greater than 1, And I need that overlap because these are ands. So paying special attention to the ends. I get that. All right, we're finally ready for the other type, which is or. And or simply means I am happy with either of the two solution regions. Now let me show you how. So they've worked these. Let's just get to the punchline here. So they work these, they graph them. Now this is or. So I am happy with either region. So this is the solution to this one, and here is the solution to the top one, and either one of them makes me happy. And so I will literally use the symbol for or, which is that union symbol, and I will tie them together. This was one or the other, and I need that U. You got to give that to me if you're going to get full credit. Okay, let's try one of these. So it's an or, and it matters. You got to get your symbol right. Okay. Now be careful here. That 2 owns that sign like it's a negative, so don't lose that. Okay, now I'm dividing both sides by a -2, so that's going to flip it around. You with me on that? Okay, so I've got x is greater than or equal to 2. Let me put them here. I'm going to put these on the same number line because they're going in opposite directions. So I would have this, and I would have, oops, no, it's a bracket. Okay, so I'd have this. Now, we are happy with either region, so we're going to read this going left to right. So I'd start at -infinity, stop at -1, give it a bracket. I'd pick it up again, so I've got my union saying I'm happy with either one. I'm picking it up again at 2, and then I would go on for infinity. Now, I'll have students scramble these all the time, but we're going to read it going left to right, going up the number line. So this would be the proper order. Okay, let's try another one. So we've got an or here. All right, so I got -5x. Now I'm dividing both sides by a negative, so it's going to flip it. Oops, I almost put negative, but so 2 negatives would cancel, make a positive. Now I'm not dividing by a negative here. I have a negative, but that's different. So I want to be less than or equal to -1 and greater than or equal to 1. Now in interval notation, we're going to go from left to right. So I've got -infinity to -1, and I've got 1 to infinity, and make sure you give me the U for the or. Okay, let's see. I'm assuming something weird's going to happen here. So let's just jump to it. So they just worked it for us. Now we've got these two where I want x to be less than or equal to this one. It should be a bracket there. Yeah, it should be a bracket, but that's not going to change anything. Okay, and then they did x is greater than or equal to 12. That also should be a bracket. Now, we're happy with either of these, but notice what's going to happen. They cover everything. If this one's going to the left, covering all the lower numbers, and they overlap and this one's going up, hasn't every possible number been covered? So everything's been covered, and so it's all real numbers. And a clever way that we write all real numbers is -infinity to infinity. Everything is fine. Everything is a solution. Now let's try another one. Now I'm distributing this again to save myself a little bit of time writing all this over. So that's a plus. So 1/3 times 6 would be 2. Okay, 3/5 x. Now we're going to multiply by the reciprocal here. That's what keep, change, flip would do if you just divided by the fraction. So this is going to cancel down to x. We can reduce that, and we'd get a 10. So we want x to be less than or equal to 10. Now we've got 1/3 x. So reciprocal here as well. on both sides. Okay, so x is less than or equal to 10, and x is greater than or equal to negative 12. Excuse me. So this one is going this way. This one is going this way. But it's an or, so I'm happy with either one of those. Well, every number has been covered, so it'd be negative infinity to infinity. Okay, I think there's probably just one more here, yeah. Now, actually, I've got to pause it here. I got to cough again. Okay, I'd recommend you try it yourself. I think you probably already know what's going to happen, the way they repeat them here. I'm just going to get started. I'm adding that 3 to the other side. Got less than or equal to 6. I'm going to multiply both sides by the reciprocal. So everything over there is going to just leave x. These can cancel, and I'm going to get less than or equal to 8. All right, I've got an or here, and I'm going to distribute the 2/5. So I'm setting 2/5 to x and 2/5 to 10. And can you see that that'll be 4? It's greater than or equal to 0. Okay, doing the reciprocal trick again. Got to do it on both sides. That'll cancel down. I get negative 10. So x is greater than or equal to negative 10. Now look what happens here. I'm not going to draw my number line, but I'd be going down from 8 and up from negative 10. And because it's an or, I'm happy with either of those. Well, that's going to make negative infinity to infinity. It's going to make all real numbers. Okay, this is a topic that gives students trouble. It is really, really worth taking your time to make sure you understand it. Inequalities, they aren't a primary focus in algebra, but they come up quite a bit. So the better you understand this and interval notation, and especially that overlap idea, the better off you're going to be.